Okay, I thought we'd do a little series that puts together some helpful recipes for synthesis. And so I think the feeling in the class a lot of times for students who are just getting started is just there's such an overwhelming amount of stuff. You know, there's this overwhelming amount of reactions. We have all these mechanisms. Um, and it can be really hard to just memorize all of the stuff that we need to memorize. And then being able to kind of put that together in a way that's useful, you know, in these kind of complex abstract problems, um, is sometimes just like it's just too much. Like it's too much to do in such a short period of time. So I'm going to try and help you realize that it's a little bit more manageable than it feels at first. Okay, so one way to think about synthesis is to just think in terms of um, like important recipes to know. So if you were learning to cook, you know, you would start by, like if you're learning French cooking or something, you would start by learning like all of the basic sauces. You know, you'd learn how to make a bechamel sauce, you'd learn how to make a roux, you'd learn how to do all these different like very fundamental things, and then ultimately you would put those recipes together into making other things, right? And this is the same thing, right? There's a lot of different things you can make, from flour and butter and milk and all these different types of things. But you know, there's some fundamentals you start out with, and for organic synthesis, it's the same thing, right? There's a million different things you could make, even with the reactions that you know now. But some of the things that we need to know how to make are just kind of fundamental, and so we can kind of learn recipes for those. And I think the first recipe, especially for the first course and the way it's taught at UT, is to learn how to make alkynes. And if you've been kind of following along with the class, you probably realize why I think that's important. It's because the alkyne reaction allows us to make, or the alkyne, if we can make an alkyne, we can make a carbon-carbon bond. Okay? And we're going to look at that in another video. But right now, let's just look on how to make an alkyne. Okay, so that's what I'm pushing towards. But here we're just going to kind of learn the recipe. So here I'm giving you propane. This is a pretty standard setup, I think, for Organic Chemistry 1. We give you the alkane and then ask you to just like turn it into something. And so what's our recipe here? The recipe for making an alkyne is to, at least from an alkane, so we're starting with an alkane, is to brominate. Let me use shorter arrows so I don't immediately run out of things. It's to brominate and then make an alkene. I really want to fit this all in the same line. One more time. All right. It's to brominate so we add a bromine there. And then we make an alkene. And then we halogenate the alkene. So we add Br2 to it. And then finally, that allows us, not going to fit it all in one line, but finally that allows us to take and use an excess of sodium amide. Usually you use 3 equivalents, and then you can work it up with water. And that we can get to the alkene from that. So you'll notice I, for the most part, didn't write in reagents. I sort of broke that in this last step here and put the reagents for this. And the reason for that is the reagents are important, obviously. Like, you know, you can't go in the lab and do a reaction if you don't know the reagents. But really what we're trying to think about here is not trying to recall the reagents, but recall the kind of the flow to making these things. So I would say, you know, I don't know exactly what the best way to learn this is, but I would say for me, what I would think about is like, just because it's so much to remember, it can be really time consuming to write. Start out by just maybe memorizing this sequence for making things, and you can memorize it using words. You don't have to draw the symbols out for it, although ultimately you want to tie those together. I think the book calls these haloalkanes. I kind of switch back and forth between calling them haloalkanes and alkyl halides. Obviously, it's the same thing. But this is a nice recipe. It takes us from this to, I guess we'll call this a dihaloalkane. And then finally to an alkyne down here. So, obviously you want to be able to actually draw out the chemistry on an exam. You can't just write these words out and expect to get credit. You have to draw out the structures. But for a flashcard or something, you could have something like this just on the back that shows you moving between these. And this sort of gets back to kind of how I was telling you to learn about things in general. When you're learning your reactions, you want to be thinking in terms of the functional group transformation. So you want to be thinking in terms of like, I know how to go from an alkane to a haloalkane. So if you've been kind of following along with me when I'm saying, oh, put this on a flashcard, you should have a nice stack of flashcards at this point that has all these different functional groups on them, or these different transformations. And really what you're trying to do now is take these little pieces, these little modular pieces, and organize them in a way that makes sense. Yeah. So I sometimes still, just because I don't do a ton of synthesis, so it's not like a world I live in, I've always done kind of, I don't know, I deal more with like other parts of organic chemistry, I guess, like say analytical chemistry and in the physics of organic chemistry. But yeah, I sometimes forget my reagents. But the important thing to remember, though, is even if you forget like a little piece of a reagent or something, if you can remember sort of the flow here, right? Everyone in this class for sure is smart enough to go back and just like rememorize their reagents. But it takes a while to kind of learn the flow of these questions and or how to set up the answers with this kind of nice flow of like, how do I go from one thing to the other? So this is our recipe, and if you want, I'll go in because I know you guys I'm sure want to see what the reagents are. To go from this to this, remember we use H nu and Br2. If we want to go from here to here, we could use terbutoxide. There are other bases that would work, but this is a good one. If we want to go from an alkene to a dihaloalkane, that's just Br2. And then finally, when we want to go to the alkyne, we want to use a large excess of sodium amide. So usually it's 3 equivalents, but I'm just going to put excess. And then in the second step, you want to work it up with water. And that's our recipe for going from an alkane to an alkyne. Right? And so you can start to think, though, a lot of times what you're pushing towards, no matter, like you're not always given an alkane and asked to go to an alkyne. Sometimes you're given something else. But then you can start to think about like what else could I be given? Like if I'm given an alkyl halide or a haloalkane or whatever. Oops. If I'm given a haloalkane, yeah, actually let me stick with that. So if I'm given this, and I know I need to make an alkyne, well, that's sort of already included in my recipe. I'm just starting a step ahead. If I was given an alkene, again, it doesn't matter, right? This recipe still helps me because I know how to go from an alkene to an alkyne. So this recipe captures a lot of different things. It doesn't just tell me how to go from an alkane, which is like the simplest thing that somebody could give you to start with, to an alkyne. It also tells you how to go from an alkyl halide to an alkyne. It also tells you how to go from an alkene to an alkyne. And so the recipe contains a lot more information than just like this singular thing of how do I go from an alkene to an alkyne. So you can think, actually let me erase down here so that we can keep this part at the top and see it without zooming out. Okay, but so we can think about like what are some other things though that aren't included in this recipe that I know that I might want to use to make an alkyne. And the first thing that comes to my mind would be maybe something like an alcohol. If you were given something like this, like how would I make that into an alkyne? So these are multi-step deals, right? This is not like there's one set of reactions that's going to take me between these. So yeah, how would I do that with an alcohol? There's several ways you could take the alcohol there. And really what you're trying to do now, like in this case, so like let's say that you've looked at this video and you're at the point where you've kind of you've gotten this series that we did up here. You understand that this is how you go about pushing from an alkane to an alkyne. So what you're trying to push towards now, right, if you know that one recipe, is you know that if you can take an alcohol to any of these things. So if I know that recipe, let me be clear. So if I know starting with an alkane I can get to an alkyne, and I also know that starting with a haloalkane I can get to an alkyne, I also know that if I was given an alkene I can get to an alkyne, and I know if I can get to a haloalkane I can get to an alkyne. So I can get to an alkyne from any of those 4 different things. And now I'm given something that's not one of those 4 different things, but the power of kind of knowing this recipe is that now I just have to think, is there a way, if I want to transform the alcohol into an alkyne, is there a way? So I could say, if I can figure out a way to go from the alcohol to any 4 of those things, let me do it in words actually. If I can figure out how to take an alcohol, that's my functional group I'm starting with. If I can get to any of the points inside of the recipe that I know, so if I could make an alkane, then I know this is not the shortest route to get there, but if I could make an alkane, right, then I know that I have this recipe that I can use to make the alkyne. So if there was a reaction that takes me from alcohol to alkane, I would say, okay, well, I don't have a recipe to take me from an alcohol to an alkyne, but I do have a recipe to take me from an alkane all the way to an alkyne. So if I can just figure out a way to take the alcohol to an alkane, then that gets me there. But even better than going to an alkane is just to try and get farther along in the recipe. So if I could go from an alcohol directly to an alkyne, that would be ideal, but we don't know a reaction for that. But do I know a reaction that would take me from an alcohol directly to a dihaloalkane? That would be the second best way to do it. And so you could think about that. Do I know any reactions? So if you've been sort of making your flashcards and stuff, then you sort of bring up alcohols and you bring up all the different types of things you can make for it. And what you realize is there is no way to do that. Just like there's no way to go from an alcohol to an alkane directly. So that doesn't work. So we're looking for direct routes between these things because that makes our life easier. What about an alcohol to an alkene? That's one we can do. So there is a direct route to go between an alcohol and an alkene. And we just learned this in the alcohol chapter. If we take H2SO4 and we use it concentrated, we'll dehydrate the alcohol and get an alkene. And once I have the alkene, I'm pretty much done because I'm starting here. So I just take my alkene that I've just made down here. So I made this alkene. I take that alkene, I convert it to a dihaloalkane, and then I can convert that dihaloalkane to an alkyne. So by getting to the alkene, I'm again plugging into this recipe, this fundamental recipe that I know for making alkynes. And that's making my life easier. But let's say that you don't remember that you don't remember that you can make an alcohol into an alkene by using concentrated sulfuric acid. We did just learn that, so maybe you don't have it filed away yet. Let's just let's say, well, you're like, oh, I don't know how to do that. I don't know how to go directly to that. Then you can start looking at other things. You can say, well, do I know how to go directly from an alcohol to this, right? Because that'll take me to this part right here where I'm at a haloalkane, and then I just plug into that recipe and use it. Sorry, I keep switching between the words and the actual structures. Can I take that alcohol and go to a haloalkane? Is there a way for me to do that in a single step? So what I'm thinking about here, when I'm looking here, I'm thinking in terms of multiple steps. I'm thinking, okay, I'm going to take the alcohol, I'm going to have to transform it through at least a couple of different things to get it to an alkyne. In my consideration down here, I may have to think about things in multiple steps, but I'm going to start by just thinking in terms of single steps. Because if I can figure out a way to plug into my recipe into one of these things at the top, the haloalkane, the alkene, or something in a single step, then I've done all the heavy lifting for the problem, or at least, I found a way to make an alkyne, which a lot of times is really all you're trying to do. In an exam, you're just trying to figure out a way to push there. We're not super strict about finding the very best route. to get there. Okay, so is there a way to go from an alcohol to a haloalkane? So again, if we remembered from our previous chapter, we could take this and subject it to HBr. And that'll give us substitution with a halogen there. So again, now we've made a haloalkane, so we're pretty much done with the problem. We know if we can start here in the recipe, again, we know how to make an alkyne. We just do the series of reactions that lead up to it. Okay, but again, let's say that you'd still, because we just learned those reactions, that you don't know how to do that. Then you end up in a situation where you'd say, okay, well, like, what am I going to do then? So I don't know how to take an alcohol, and I don't know how to plug it in directly to make any of these things. I just don't remember how to do that. Okay? That doesn't mean that you're necessarily stuck. Now you just have to kind of consider maybe you have to go multiple steps, so more than one step to go from the alcohol to one of these points on this recipe. So I'm saying, is there any way that I can imagine taking an alcohol to any of these 4 different points on that recipe? Even considering things that I can't do just in a single step. So not just going from an alcohol to an alkene or an alcohol directly to a haloalkane, but like what if I broke it up over multiple steps? So you've forgotten some of your reactions. This happens. You know, we're human. This is a lot of crap, a lot of abstract crap to remember. So now I'm just trying to figure out maybe there's some other routes. And so now you just have to get kind of creative. You might say, well, you know, I look at this. I look at... There we go. So I look at this over here, and I'm thinking, okay, I got an alcohol. Like I want to make a haloalkane. This is when I start, when I get desperate, I guess, and what students do generally when they get desperate, and I don't mean that in a bad way. Like when you're like, I don't know what to do, what you really want to start to think about is like the substitution chapter, because the substitution chapter allows us to do a whole lot of different chemistry. It allows you to be really creative because you can take any nucleophile, and if you have a good leaving group, you can replace that leaving group with that nucleophile. You just have to be careful. Remember that you're not doing elimination, etc. So, and so we're on a secondary carbon, and I'm not going to get too bogged down into the details of the E2 stuff because I think that's going to cause more stress than it's worth. But you can think, okay, I got an alcohol there. I need to make it a good leaving group. Like one thing I could do is just tosylate it. Now I've made this into a good leaving group. And now I can use some SN2 chemistry here and say, okay, I could do Br minus. And now I've got a haloalkane, so I'm right here, and now I'm plugging back into that recipe again. So I'm back on my recipe. I know how to make an alkyne from there. Or I could say, why would I bother doing that when I could just take this and say treat it with terbutoxide? And now I've got an alkene, which actually gets me farther along in my recipe and reduces the number of synthetic steps that I have to do. And then I can push along to the alkyne. Okay? So there's a lot of different routes that you can take to sort of get to kind of get to an alkyne. But typically, I'll say typically, your stopping point to getting to an alkyne is going to be most likely going to be, let me make my eraser smaller. Your point, if you're trying to push towards an alkyne, usually what you're trying to do is push towards an alkene, really. Okay, or maybe a haloalkane, but typically it's going to be towards an alkene. So regardless of what you're given, alkenes tend just to turn up a lot to be really, it's like kind of like a hub for synthesis, in that there's a lot of different things we can do to an alkene. So we know, I guess what I'm trying to say is we know a lot of different ways to make alkenes. All we really need is a good leaving group, and then we can hit it with a strong base, and we can make an alkene that way. But if you think about, like, well, what are all the different ways that I know to make, one of these dihaloalkanes over here? Let me use a different color. What are all the different ways I know how to make this? There's not really that many ways, right? Like I only know, I mean, really, I only know one reaction to make that, and that's from an alkene. And if you look at some of these, if you're looking at one of the roadmaps or something, like I think the Iverson book has, or I'm sure you can find them online, you'll have these different little like hubs and stuff, and we can maybe look at that in a different video at some point. But you have these little hubs and stuff that you're sort of trying to connect. So, you know, that the synthesis is sort of organized in a graph, and those graphs have different nodes. And if you look at the different nodes, you'll notice like alkenes has a lot of connections. So, you know, if I was looking at alkenes, I'd have all these different connections to it, and that connectiveness to it sort of emphasizes sort of the importance. So, you know, over here you'd have other functional groups that were other nodes. Oh, trying to go too fast here. Let's see, let me get a different color palette. Good enough. Over here you'd have the different colors would represent other functional groups on here, and there are a lot of different functional groups that you can transform alkenes into. And then outside of that, you would have these things connected to yet other nodes. But the main thing to think about here is that the number of connections to a particular functional group on one of those maps sort of emphasizes the importance of that functional group. Because if I can make a lot of different things from alkenes, that means it's just like a very useful intermediate. So just like if we go back to the original thought about cooking, when you learn about sort of fundamentals for cooking, what you're learning about are things that are usually intermediates in other recipes. So like if I learn how to make a roux, for example, which is just like a beginning for all the different sauces for French cooking, you know, that's a very useful thing to know, because I can take a roux, I can make a bechamel sauce, I can take a roux, I can make like a veloute sauce or something from it. I can make all these different sauces from this one thing. So it's really important before I sort of try and run and sprint and make something really complicated in French cooking, like, you know, if I was trying to make some sort of, the only thing that comes to me right now is like ortolan or something, but like some ridiculous, you know, French haute cuisine thing. Before I can go ahead and do that, right, I need to learn these fundamental things, and I need to learn those fundamental things because from those, I can sort of build on them and make all these kind of really interesting things. And that's what you want to kind of think about when you're thinking about synthesis. So alkenes turn out to be really important. And I've sort of focused on, in this video, I've sort of looked at how we make alkynes. And alkynes are, in some sense, like ultimately when you get to the second course, alkynes become much less important, but they are super important here. And the reason for that is that we know how to make carbon-carbon bonds with them. And that's the only way that we know how to make carbon-carbon bonds. And so ultimately, for most of these synthesis problems, if we're going to make them challenging at all, we have to kind of have you pushing towards making an alkyne. And as we'll see in the second course, there's a whole lot of other ways to make carbon-carbon bonds, some of them much easier than using alkynes, and that sort of opens things up. But for now, you can kind of capitalize on the fact that that's the only way we know how to make carbon-carbon bonds, and so you're always kind of pushing towards an alkyne and ultimately an alkyl halide, and sort of understand these other sort of more fundamental aspects of synthesis, which is like, oh, okay, I have to do all these transformations and stuff, and like what are the most important transformations? So pay close attention if you're looking at one of those organic chemistry roadmaps to the nodes that have a whole lot of different lines coming out of them. Those are sort of like the really important airports that have a lot of different flights out of them. And you don't necessarily have to use a roadmap. Like that's not how I learned it, and it's not really exactly how I think about it. But it is kind of a nice visualization for looking at things. Okay, so yeah, so this video I show you how to make an alkyne, and the next video I'll show you how to make an alkyl halide. But try to spend some time on this and think about what I'm saying about this recipe. And once you know the recipe, that if you can just find a connection into any part of the recipe, you can ultimately use that recipe anyway. So even if you're given an alcohol like we were given here, there's still ways to push towards an alkyne and leverage that you've memorized this recipe. And that's how you want to kind of organize these things in your head. Okay.